All right, thanks everyone for attending. I know this is the last talk of the day, and I appreciate everyone here. This is less product-oriented than the others, so I'm going to assume you're all here as die-hard fans of production, which is what I am. So this morning we heard from Joe Cava talking about the hardware and data center side of the Google Cloud Platform, and I'm here to take you on a whirlwind tour of how we support the software side. My goal is that you walk out of here understanding how Google keeps an infrastructure like this together, but that you also have some ideas that you can take home to your teams, both organizational and tools. At the end, I will stay up here if there are any questions, and I know it's late and everyone wants to beat traffic. I have a set of business cards, so if you just want to grab one and run out and send me your question, I'm happy to answer it later. All righty, let's get going. So, first a bit about me. I joined Google only a year ago. This means I've actually seen a lot of the places that you guys are working. I've worked in 10-person startups. I've worked in 100-person startups. I've worked in a retail company attempting to reinvent itself. And I also spent almost a decade at Amazon, where I was building internal tools and automation. If any of you are familiar with AWS Code Deploy, I designed the internal tool that that's built on. I know baby pictures are traditional, but I figured you would get a lot more enjoyment out of my 1980s haircut. So here's a picture of me with Bob Ballard. This has not been shown publicly before. Enjoy it while you can. All right, next I'm going to talk about SRE, the what and the why. First, I want to tell you a story about cookies. Everyone likes cookies. So let's start with sysadmins. What do sysadmins get cookies for? Sysadmins get cookies when the site stays up. Site stays up, we get visitors. Visitors give us money. Yay! Cookies for everyone. U is for uptime. How about developers? What do developers get cookies for? Developers get cookies for features. Release a new feature, visitors come, they give us even more money. Yay, cookies! Before I continue, I want to ask you to go home and put together an experiment. Have your developers stop releasing code for 2 weeks and let me know what happens to your site availability. Maybe you guys work at a place that has a production freeze for big business reports or for holiday stuff. And the fact is that production freezes usually result in higher uptime. So you have these two competing priorities. Your sysadmins get cookies for keeping the site up. Your developers get cookies for releasing features. So these two teams start to figure things out. The sysadmins will get more cookies if they can prevent features from going out. And the developers will get more cookies if they can figure out a way around the sysadmin's rules. So devs figure out they can call it a beta. It's just a beta, guys. It's OK. Not a big deal. And the sysadmins figure out that they can demand launch reviews and stretch those out for a really long time if you do it right. Developers go, oh, I have an idea. We're going to do a percentage flag flip. That's a good idea. So you end up with this fighting back and forth and sadness and no cookies, because all your teams are spending all their time fighting each other, and your conflicts are handled by rules and process, or sorry, excuse me. You get increased outage, increased risk, chaos, anarchy, dogs and cats living together. So what we want is to actually take all of this women fiat out of the process, have it handled by individual rules, or sorry, handled by rules so teams can have goals and work together. Now, there actually is a common solution out there for this dev and operations problem. There are conferences dedicated to dev and operations. Anyone have any idea what those are? Yeah, DevOps. So the problem with DevOps, I don't know if you know the story of the blind men and the elephant. But it's a set of blind men who go, and one guy feels the trunk, and it's kind of leathery and bumpy, and that's what he decides the elephant looks like. Another one feels the tusks. Long, smooth, cold. That must be what the elephant looks like. Another feels the tail. DevOps is a little bit like this. It has different meanings everywhere you go, different interpretations. So is Agile, so are various other things. So I'm going to talk about SRE, because SRE actually is well defined. In short, this is SRE. There's two key phrases in this quote from Ben Traynor: software engineer and design and run. Software engineer is critical because it turns out services run better when people who understand software also run it. They have a deep understanding of what makes it tick. They have a deep understanding of the interactions. And design and run. When you actually design your production environment, rather than having it be a happy accident or something some dev did while hyped up on some really good coffee right after drinking, you actually have a better environment. There are many, many different aspects to SRE. I am not going to try to discuss all of them. But it's all these activities that actually make up what we call SRE. So let's say we have 1,000 SREs working on Google's infrastructure, network, compute, storage, et cetera. How many of them do you guys think are responsible for cloud? Maybe 100 of them, 10%? 200 of them? I'll give you a hint. SREs in every office we have around the world work on cloud. It turns out the answer is that all of our SREs who support our infrastructure also support cloud. We don't want to distinguish between what makes Google.com run and what makes Google Cloud Platform, and therefore your applications run. We don't want to have communication overhead as the cloud teams and the internal teams try to communicate. We want to create one environment that helps everything work together. The rest of my talk is how we created those teams, how we run those teams, and how we do what we do. So first, how do we structure SRE from an organizational perspective? How do we make sure we hire devs into a role focused on production and keep them happy? How do we keep the team valued inside of Google? And how do we help our teams communicate better and resolve disagreements with data rather than assertions or power grabs? So first, it's all about leveling the playing field, having common tools, having common knowledge. All of our SREs have to pass a full software interview to get hired. In addition to that, they have to pass a non-abstract large system design interview. So in some senses, although I would never tell this to my devs who are sitting here in the front row, our SREs actually have to be more skilled than our devs are to do the same job. They need to have a greater breadth of skills. So it's the same software skills, the different domain of application. Devs are beholden to product managers. They make features. They make you guys happy. SREs are beholden to production. They're beholden to making production as good as it possibly can be. So when both of these different perspectives contribute to a design, the resulting design is much stronger. Here's an example from an onboarding that a friend of mine did. They evaluated the team software, and they found that there were a bunch of assumptions. It was going to fail in production when we hit scale. The devs had implicitly assumed a particular type of call would never fail. They had assumed the distribution of the requests was uniform. They'd assumed they wouldn't get hot-spotted by users. They'd assumed that all of their requests were average-sized, and they failed on the two tails. But that's what our SREs bring to the table. Then we need to give our devs a reason not to just allow operational work to build up, because if they're not doing it, why would they care? So we do this by having our devs actually provide the headcount to SRE. So if you have a system that has a really large operational overhead, you don't get as many devs. You don't get to push as many features because we look at the headcount in aggregate. We also have SRE report to an entirely separate organization. They have their own VP, separate from the dev VPs. This gives them authority and power. It allows them to say no when production means they need to say no. They're not just a bunch of pager monkeys. There's also scarcity. The devs say that they can donate headcount. SRE doesn't have to accept it. They can say that's great, but we don't think that service is actually important enough. Why don't you keep supporting it yourself? Not every team at Google has SREs. Cloud does, but not every other team, and not every single small service in cloud. It's the important ones. So I'll talk a little bit more about that in another slide, but the main point is that SREs are scarce. The environment, very critical. So this is how you actually keep these devs happy running in a production team. You need to have at least 50% of your work being project work. So that's not on call, that's not tickets, that's not meetings. You actually have to be doing project work. And if there's too much project work, either the devs give more headcount to SRE, or that work actually flows over into the dev team. Example project work for SREs, improving the latency of a service by switching the underlying database technology, writing automation to speed up deployments, and projects that span services, We have a service internally that can be queried by other services, because we make robots do everything for us, not Boston Dynamics type of robots, but software robots. So we have a service you can query internally that says, hey, is it safe to take this machine down? Is it safe to take this rack down? Can I take down this data center? That actually syncs with the state of everything else and gives a yes or a no. And that's maintained by SRE. And possibly most critically, our SRE teams are a volunteer army. There is no draft. Not only can you transfer to another SRE team at any time without your manager's permission, although this applies to all devs at Google as well, but you can transfer into dev. So if you're tired of dealing with production, you just really want to sit down with a product manager and become best friends, you can transfer to dev. You don't have to ask anyone's permission to do it. We actually even have the reverse, which is mission control, where devs can try out SRE and see if they like it. One of my teams has 2 mission controllers on it right now, really hoping they'll stay. If you're watching this, guys, we want you to stay. So as a result, the teams are fluid. People are coming in and out of the teams, sharing experiences, sharing perspectives. And finally, we have a budget. This isn't a money budget like you're used to. This is an error budget. If I tell you you have 3 nines of service availability, I don't want you to go, wow, I'll bet I can push that to 3.5, maybe 4 nines if I'm really, really good. You have 0.1% error budget. Go for it. If you want to push out features faster and make GCP even better, do it, right up until you run out of error budget. If you instead would prefer to have poor tests, have your software failing regularly and have to roll back constantly, then you can choose that too, but you'll run out of error budget much faster, and you actually won't be able to launch. And so these error budgets go on quarterly cycles. Now, there is an escape valve for that. It's called silver bullets. Some teams have literal, actual silver bullets, and a dev can come up and say, I really, really need to push. I really, really would like a silver bullet, please. And the SRE will say, no problem. You just have to convince the VP that you actually need to push. And that little ritual, which sounds very silly, is actually very powerful, because it puts it entirely in the hands of the devs. They know they have 3 silver bullets, and their VP is the one that decides whether or not it's appropriate to push. This even applies if you have multiple dev teams working on a service, because error budgets are on a per service basis, not per team. So SRE does not get in the middle of warring dev teams. They have to work out amongst themselves how that error budget's going to be spent. So we do have an escape valve. If all else fails, there is an irreconcilable dispute, SRE can offboard, it's the opposite of onboarding, a dev team. Basically, we've loved working with you guys, but we have irreconcilable differences, kind of like an amicable divorce. It's rare, but it has happened. It's a very critical escape valve to make sure that you don't have teams festering disagreements for long periods. An example reason for this might be if you have, say, a common database at Google that's encouraged for all new ACID-type projects. We might call it Spanner. And new projects are supposed to use it. The devs team says, you know, Spanner's cool and all, we're going to go build our own. It's very reasonable for the SRE team to say, I understand that, I disagree with your reasons, and we actually don't want to support you if you go and build your own database technology because we think that's not good for production. SREs are the custodian of production. They're the custodian of the customer experience for Google.com and for GCP. So we try to avoid this. I mean, it's maybe 1 or 2 times over the history of SRE, but it has happened. And it's not the end of the world. There are teams without SRE teams. They'll survive. SREs support their teams in a lot of ways. It's not just about taking pages, although I can assure you that's usually what I'm asked very first when I'm interviewing someone. So you guys get paged? SRE support is on a spectrum. So it can go on one end to simply chatting with a dev, consulting with them about a service, doing a little whiteboard session, to full-on producing a design doc together, or in the very extreme, yes, actually fully owning a service, all of the capacity, all of the provisioning, all of the pages. We don't really think of pages as the sort of headliner of what SRE does. Pages are kind of a way of keeping you honest. So the people responsible for production should take the pages because that keeps their skin in the game. and it helps keep the SRE skill, expertise, and perspectives up to date. All right, let's talk a little bit about what makes things go. I'd like to talk about the culture and processes, but it's not the scary P processes, they're good processes. So in addition to training and on-call shadowing, which you guys probably do at your companies, we like to run a role-playing game, if you will, where one person is the dungeon master, and they have a victim, perhaps the class SRE level 5, lawful neutral alignment would be my guess, or the whole team, and they take turns trying to guess what's actually going on. We run very complex systems at Google with a lot of different dependencies, so it's rare that someone other than the dungeon master or the person running the training session actually fully knows what the answer is. It's good for our new on-callers, lets them actually test things out in a controlled environment. Some teams actually even have entire scenarios they can run where they actually break something in prod and have the newbies fix it. But it's also good for the veterans. When you have very involved systems, it's good to refresh your knowledge. It's good to figure out, oh, that's right, that's how that thing works. All right, brief break in the talk for a quiz. So, you're on call for Gmail. You get a ticket that says users can see other users' emails. What do? You call your team lead, call your VP, call for a pizza, or do you shut it down? I actually ran a test on this with some non-Googlers. Most people answer A. The answer is D. Our on-callers are fully empowered to do whatever it takes to protect the users, to protect information, to protect Google. And if that means shutting down Gmail, if that means shutting down all of Google.com, you, that college hire who's 6 months out of school, who just got paid for your first time, are going to be supported by your VP, by your SVP, for shutting it down and protecting Google. And we actually don't need to worry about making sure that we troubleshoot. Our goal is to restore service immediately. We have records of the binary state, we have logs. We'll troubleshoot when we're awake, when the devs are in the office, when everyone's actually there. We just want to get it back up and in service now. All right, next quiz. Everyone still awake? When good software goes bad. So you have a new dev. Maybe this is another college hire, but on the dev side. The new dev pushed code, broke Google.com, the entire search engine, for 3 hours. Who's at fault? The dev? Quality of the code reviews? Lack of tests? Lack of proper canary process? Lack of rapid rollback tools? Everything except the new dev. The new dev shows up and writes crap code that takes down your site. It is not the fault of the dev. It's all the gates between that dev and working prod that should have stopped him, and that's where you should be looking. Yes, people can screw up, but most of the time, human error should never have been allowed to actually propagate beyond the human, at least not as far as prod. That brings us to our probably most critical culture point of all, just blameless postmortems. Studies show that most incidents are actually caused by human error. You heard Joe say that they'd gotten the incident rate down really far in the data centers. That's awesome. Software has not yet, including software written by SREs. We still have as the highest cause human error of one form or another. And it turns out incidents are best solved when you know what actually happened. You know the best way to not know what happened? Open every incident with trying to find someone to point a finger at. Because people are really good. They become really good at hiding, at making sure there's no trail, and at making sure you don't actually know what happened. And you've just made your job 10 times harder, 100 times harder, 1,000 times harder. So avoiding a blame culture is critical. At Google, the general practice is whoever screwed up writes the postmortem. This avoids naming and shaming. This gives them the power to make it right. Multiple people contributed, which is very common. Everyone goes in as honest as possible, put in how you screwed up. We've actually given bonuses out at all hands meetings for taking down the site, because it was someone who owned up immediately that they did it. IRC, oh boy, hang on guys. Rolled it back, and they got a bonus for speaking up and taking care of it so quickly. And in the event of major outages, it's actually not unheard of for a VP or an SVP to kind of ping someone and say, it's okay, It's okay. No one's blaming you. We've got your back. It'll be all right. Blame us doesn't mean there's not names or details. Obviously, we need to look into that. But it means we're not picking the people as the reason things went wrong. There shouldn't be any such thing as an outage that deserves a firing. We have a detailed postmortem template that separates out actions into prevent, detect, and mitigate because we want defense in depth. We don't want to just go, yeah, well, we did all those things that we needed to do, and now it'll never happen again, because odds are good it'll happen some way. Maybe you missed something, or it comes in another angle, or whatever. We want to, yes, prevent outages. We also want to detect them faster, and want to mitigate the impact. So if something like this happens again, it at least won't spread as far, or last as long, or affect as many customers. All righty. In the short time remaining, I'd like to talk a very little bit about how we actually do our job. We really lean heavily on visualizations. But first, I want to talk about the kinds of pages we like to see as a team. Pages you know how to solve are boring. Make you ask if there isn't a better way. Maybe you should invent a robot. We invent lots of robots. We don't like being bored. We don't want to sit there dreaming of a better world in which we aren't paged by boring things. If you can write documentation to fix it, just fix it. If you can write down the steps that clearly, you can probably write the automation. If you can't, go write something that lets you write the automation. Don't be doing things that robots can do for you. Pages, if you're getting recurring pages, stop them from happening. So the result of this is that each page we get is ideally really new. So we don't have boredom. We definitely don't have boredom. This means even our experienced engineers are probably seeing something new every single time their pager goes off. This is a fundamental change in philosophy. If nothing is routine and few incidents are repeated, this means you can't lean as heavily on your previous experience when debugging the system. It means you need much stronger debugging tools. This is not a debugging tool. This is an obfuscated view of variety of messages on my Mac, but you get the point. Standard debugging, like looking for patterns in log files, it doesn't scale if you don't know what to look for. And with a platform the size of GCP, how many machines logs am I going to look through until I hopefully find the one that was failing? So we rely very heavily on various visual tools to help us troubleshoot unfamiliar problems and restore service as quickly as possible. Graphing tools, in the next few slides, I will have some open source tools mentioned. I am not advocating these tools in particular. I am not saying we don't use these tools. These are examples of what we do. So you can use these as a springboard. They may be useful. You may use them to find other tools. Graphing is a very traditional form of visualization. It's great when you're looking at a single thing. It's even better when you're looking in aggregate. For processes that we care about at Google, there's never just one. There's billions and billions and billions of them. So each of these lines, while they look simple, are actually pulling from many different sources and getting aggregated. We instrument the heck out of our binaries because, again, with a novel situation, you don't always know what you're looking for. Ideally, you have a framework that makes it easy for your developers to actually export data into your system. Developers get bored just like ops people get bored, and they have just as much fun, none, writing repetitive monitoring code. So come up with a framework, find a framework, whatever you need, so that this is actually simple for your devs to do. I mentioned this before. Possibly most critical is that there's actually a huge amount of storage that we have behind this, solely to store this data, because we do not want to be troubleshooting in the middle of an outage. An outage is all about restoring service. Troubleshooting is what happens when you're awake. Our devs are often engaged in troubleshooting. They have the deeper knowledge. They know where stuff's going on. So you need to have this data historically so you can look at it and not go, well, we fixed the outage, but we lost all the data that was going to tell us what was going on in the first place. And this helps keep our unusual outages as short as possible and lets us dig into what goes on later. Event graphing is really, really useful for correlating events. Take advantage of your human ability to pattern match. It's actually kind of hard to write robots to do this, although, I don't know, DeepMind solved Go, so maybe it'll take this away from us too. So this is laying things out by data center and by time. And then the color, and I apologize if that's hard to see back there, the color is actually the event type. This can help you find patterns that aren't single incidents, like say a software rollout that's causing cascading failures throughout the whole stack, or a cluster of errors that's repeating together. Or if you see a latency spike and then an error spike immediately after it, and that's repeated. These will all help you get to the root cause of what's actually going on. Visual process tracing. I apologize, I could not actually find a lot of truly open source options for this, although there's a whole bunch of ones you can pay for. When you're looking at performance issues, you sometimes do need to get down to the process level. We have a pretty elaborate framework that pulls sample queries into storage and actually provides a full trace of them. The advantage to having a tool that allows you to do it visually is you can actually collapse and expand and compare things a lot better than if you're looking at a series of timestamps and trying to go, okay, how many milliseconds is there? And doing a lot, maybe you're better at math in your head than I am. I don't know, I'm not good at it. Network flows and capacity. So I work in storage. It turns out that a lot of storage is slow problems, not all, but many, are root caused in the network. And you can be sitting there staring at your storage system, staring at your processes, and going, what the heck? And the problem was way, way, way far away from you and the networking team. So being able to quickly see what's the state, what links are overloaded, how many packet errors are you seeing, is the link entirely down? Really useful even if you are not personally responsible for the network. When all else fails, yeah, it's all about log files again, unfortunately. But what you don't want to be doing is grepping through these logs. Having a system that allows you to have SQL-like queries where you can actually dig into them more sanely than trying to come up with the correct regular expression that'll filter out exactly what you want, extremely useful. You want your logs to be easy to consume, easy to understand. And there's an open source option there. You can also have Kibana as a potential visualization. All right, before I end, there are two more things I want to bring to your attention. One is, if this interests you, we have a book. It's not out yet. It comes out in April, and it's actually getting officially announced at SRE next week, but they told me I was allowed to mention it here. This is a sample of some of the topics. This is not at all an exhaustive list. It was written by actual SREs who are doing actual SRE work. We had 70 different contributors, 500 years of Google expertise into it, and it's a crazy thick book. I'm really excited by it. So if this was interesting, all of this has gone into in way more detail, along with some other stuff in the book. I highly recommend it. Also, I don't know how many of you were able to be in for the announcement for this, but we actually have gotten one of our tools to be usable in GCP. So Stackdriver error reporting, excellent tool. We would like to do more of this. We have an extensive ecosystem internally that we would like to make available to our cloud customers. In fact, we would like it to be available to you, period. That can be challenging. It's a little bit easier if we can at least make it available on cloud. Errors are grouped and deduplicated by analyzing their stack traces. Talked a little bit about that before. And the system knows about the common frameworks that you use in your language and groups errors accordingly. So please check it out. It's very cool. It's in beta as of, I believe, today. Alrighty, we are not doing questions. There we go. Thank you for your time today. I made this short so you all can slip out. Thank you.